Okay, so looking at this, like I said, we are going to, you add the same number of hydroxides as that you added hydrogens, but you add it to both sides. So the side where you have both the hydroxide and the hydrogen, those combine to form water, because it's like you're neutralizing it. Now, to clean this up, you're going to cancel whatever you can. So for example, the water that's on the product side can cancel out one of the waters on the reactant side. So cleaned up, this would be, we have 1 water plus iO4 negative 1, iO3 negative 1 plus 2 electrons plus 2 hydroxide. Okay, if you have balanced this correctly, you should have I just realized I made an error. I was counting, I'm like, this is not right. So the 2, we said gain 2, and then I put it on the product side. My apologies. So we're just going to change. So to be honest, it doesn't change anything else that we've had to do. Plus 2 electrons. So this is going to be plus 2 hydroxide. We're going to clean this up. You probably noticed that as I was saying it and doing it. So 2 hydroxides and then 2 electrons on the reactant side. So anyways, as I was going to say, how you can check that you did this right, and I just did now, you should have obviously the same number of elements on both sides, and your charges should be balanced. So that's a nice way of checking with that as well. So I have 2 electrons plus a negative 1, so that's negative 3. Here I have a negative 1 plus 2 negative 1s from the hydroxides, which is negative 3. So that's balanced. Okay, let's take a look at the next one. So basic. So we have OOHE, and then at the end, we're going to add our hydroxides, right? Like afterwards, so not right now. Actually, let's not confuse ourselves. Okay, so the first thing we're going to do is we're going to balance the other elements. So that's bromine. So we need 2, because we got 2 there. So then we have oxygen. So we did that guy. Oxygens, there are 6. So I'm going to add 6 waters to the right. So that's this. For hydrogens, we just added in 12. So we're going to add 12 hydrogens on the left. And then look at our electrons. So actually the product side is all neutral, but on the reactant side, so this is 0, we have positive 12 and negative 2, so we have positive 10. So that means in order to get the 2 sides to equal, we need to add 10 electrons to the reactant side, right, in order to get it to 0, so that they're the same. So we have everything done thus far. So the number that we just added for hydrogen, so this is where the basic part comes in. The number of hydrogens we added, we're going to add the same number of hydroxides to both sides. So 12 OH on each side, which means now we would have 12 waters, and then 6 waters can cancel out with 6 waters, right? So you just have whatever's remaining. So our final answer should be 6 waters plus 10 electrons plus 2 BrO3, making Br2 plus 12 hydroxide. So on this side, we have negative 12, and this side's negative 12. Done. Okay. So it looks complicated, but I mean, honestly, if you just take it step by step, add along the way. If it's basic, make sure you neutralize and you add the same number to both sides. Cancel, clean up where you can. Okay, so steps for balancing redox reactions when everything's together. So all of those were half reactions, right? So now we're going to be looking at what happens when you have the full redox together. So it's essentially going to be the exact same thing, except it's going to take you a little longer because you're going to have to separate it into the half reactions first. So the first thing you would do is you write out the half reactions. Then we balance the half reactions the way we just learned. And then here's where it's going to be different. So before we can put the redox back together to make a full balanced reaction, you have to make sure that the number of electrons gained is equal to the number of electrons lost. So if they're not the same, you're going to have to multiply the half reactions as needed by a whole number integer to get the electron count to be the same. So let's say, for example, one is, I don't know, let's say a losing 2 electrons, right? And I have something gaining 3 electrons, right? So if I have something like this, I could not add those two together yet because this is 2 and this is 3. So you would have to get the lowest common multiple, right? So I would want to make that 6 and 6 so that I can have you need the total number gained to be equal to the total number lost. That's actually why we're balancing this, is because the charges have to be balanced. Then, once you add the half reactions together, if it's basic, that's when you will then add in your hydroxides. You could actually balance your hydroxides at this step or at the final step. It's going to do the same thing at the end of the day. And we clean up wherever needed. So let's take a look. So here we have, and then it says this is an acidic solution. So we have H3ASO4 plus zinc, making ASH3 plus zinc plus 2. Okay, so the two half reactions are usually pretty easy to identify. You put the things together that look like they should be together. I know that's really weird to say. You could, to be honest, the proper way is you could assign the oxidation number for everything, but you can usually see, right? Like the zinc's going to go with the zinc. The one with arsenic is going to go with the one with arsenic, right? So you're going to write out the two half reactions. Oops. And then now we're going to balance each half reaction out by doing the same thing we were doing before, the OOHE. Okay, so let's do the one on the left first. So arsenic is the other. We have 1 and 1, so that's good. We have 4 oxygens, and we need 4 waters to do our oxygens on the right. Hydrogens, we have, let's see what we got here. We got 3, and then here we have 3, but we added another 8 from the waters, so we need 8 hydrogens on the left. And then if we look at our charges, we have positive 8, and actually we have positive 8 and 0. So we need to add 8 electrons to the left to get this also to be 0. Okay, so this guy's done. So everything's cleaned up so far. Okay, so let's look at the zinc one. Zinc one's nice and easy. So there's no other things to balance. We have 1 zinc, no oxygens, no hydrogens. We just have to actually put in the electrons. So we have 2 electrons that are lost on the product side to get that to be 0. Okay, so now that we're doing this, we have to look at the number of electrons to make sure they're the same. So here we have 8 electrons that are being gained, 2 electrons that are being lost. So we cannot add these 2 up together. So we have to get them to be the same number. Okay, so obviously the lowest common multiple here is going to be 8. So that means the entire half reaction has to be multiplied by 4. So this is now going to be 4 zinc ions, 8 electrons. Okay, so the whole half reaction is being multiplied. Now we're going to add together those 2. So all of the reactants are going to be written out. So let's do our first reaction. H3ASO4 plus 8 hydrogens plus 8 electrons. And I'm going to write in all of the reactants on the other reaction as well. So 4 zinc. Basically, you're combining the 2. So everything that's on the reactant side is going to go on like one reactant side. Everything that's on the right-hand side or the product side is going to go on one product side. Plus 4 zinc plus 8 electrons. Okay, so if this is done properly, you should have the same number of electrons on both sides, right? So we can cancel those out. If there was anything else you could cancel, okay, so if I had waters on both sides or hydrogen ions on both sides, then you would cancel whatever you can, right, to clean this up. In this case, this is the only thing, so this is actually the end of our story here. So the final cleaned up version would basically be the exact same thing, except with the electrons removed. Okay. So let's take a look at our next one. So we're assuming this is a basic solution, acidic solution as well. So again, you can see the half reactions that are going to go together, right? So you have the carbons and then you got the nitrogens. So let's do our first one. So C2H5OH, arrow, CH3COOH. Let's do this guy first. OOHE. Okay, so the other ones are carbons. So I have 2 carbon and I have 2 carbon. So actually that's good. Oxygens. We have 1 versus 2. So that means I need to add a water to the left. Right, so oxygen's done. Hydrogens, we have 2 plus 6, so that's 8. And we have 4 on this side, so we need another 4 hydrogens. Okay, so for charges on the left side, actually it's neutral, 0. Here we have positive 4, so I need a negative 4 negatives in order to balance that out. Okay, so that first one is done. Let's do the next one maybe in a different color. Okay, so then the second reaction is going to be NO3, arrow, N2O4. Okay, so we're going to balance out the other guys first, which is nitrogen. Oxygen, we have 7 versus 4, so we need 3 waters. Did we do that right? No. Oh my gosh, I can't even count. We have 2 times 3, which is 6 versus 4, so we need only 2 waters. And that is our oxygen done. Hydrogen, we have nothing, plus we've got 4, so we need to do 4 hydrogens on this side. And then our charges is the last step. So we have on the reactant side, we have plus 4 and negative 2. So we've got a total of plus 2. And we've got neutral on the right. So actually we've got to add plus 2 electrons. Okay, so let me get rid of this here so we already know what's up with that. Okay, so now we're at the point where we're going to add our 2 half reactions, but we need to make sure that they're the same number of electrons. So we have 4 versus 2. So that means that this whole entire second step I just wrote out, the second reaction, is going to have to get multiplied by 2. So not just the electrons, but everything there, right? 4, this is going to be 8 hydrogens and 4. Okay, so let's add them together. So everything that is on the reactant side is going to be written as one reactant. So we're going to have, let's do our red part first, plus C2H5OH, plus 8 hydrogens, plus 4 electrons, plus 4 NO3, arrow, and everything that's on the product side. So we have CH3COOH plus 4 electrons plus 4 hydrogens plus 2 N2O4 plus 4 H2O. Okay, so we're going to clean up what we can. Your electrons are gone. We also have some other things we can clean up here now. So we can cancel out 4 hydrogens. So 4 of those 8 hydrogens can cancel. And we can also cancel out 1 of these waters. So we'd be left with 3. Okay, and then our final balanced equation is going to be everything just rewritten with the cleaned up version. Right? It just becomes a lot of writing, okay? But the steps are pretty straightforward enough, right, that you can do that. All right, so before we get into the next part, we're going to talk about, we're going to get to the last part. We'll talk about different types of redox reactions you're going to come across, and then we'll look at some of these different approaches.